close that and go directly into the Wellbore section. So this is our second main point. So you see we have this pane and the second one and then third one. Configuration date initial, so automatically, yeah, you can see the message first, starting date from which current configuration is applicable. So automatically the Harmony Enterprise will consider the date of your on-stream as the configuration date. Okay, so the first time the well produced, so that will be the configuration date. And temperature deviation survey. So let's do this first. Casing, we have, section type, top depth, bottom depth, and then inner diameter, roughness. Okay, so let's deal with this one. Section type, production casing, starting from 0. Okay, starting from 0, and then we need to input for the bottom depth. Let me check my data. Okay, so 1043 and a half inches. So inner the catalog. Okay, so you can standard tubing, coil tubing, casing, standard pipe, and custom. And if I check my data, preparing the data is the most maybe. So that's what. So for my data, J55. Okay, so I will save the weight 0.5, 50. Good, so beautiful. So at 2000 minus 5.71. So it's located at 2.6. Let's open this one again. Tubing, it's like this one. And again, we need to make our one. Click on OK. All right, so I mainly focus on the case you will use metric unit. It's okay. Okay, so we have our tubing data there. And bottom is, I need to check it first. Okay. 886. Okay. And then it's at 2896. Okay. And yep, flow proportion 100%. It's good. And then flow path. You see, the picture is still blank like that because we haven't used the flow path that gas and liquids take from the producing formation to the surface. So let's click on this one and see there. So the green color shows the flow path zone. There must be the annulus, the casing site after the tubing. And then we have our of perforation. Okay, so it's just, so change it manually if you want. Okay, so like this, you can type the datum that you have, but okay, but I will leave it as it is. Really important. So the best way to select the correlation is finding based on the literature what is the best correlations to be used. No, but you actually gradient matching. You need to have the data, and sometimes the correlations can be changed, changing water cut, changing gas oil ratio, something like that. Sometimes correlations can be changed if you increase, if you have the friction of the tubing increase because of the older, now your tubing, become old. So of course the friction will increase. The correlation can be changed. Okay. So in this step, in this case, I will assume, okay, that the correlations that is applicable is, yeah, Haggard and Brown. You can see here, this is the recommendation from Harmony Enterprise. Bex and drill, generally applicable. Gray, predominantly gas. Okay, in my experience, gray most of the time good for gas with low water gas ratio. Single phase gas ignores liquid rates, and brown, predominantly oil. In brown, I assume no excess pressures. Okay, so now it's good already. Okay, so in the temperature, we have two methods. The first one is linear profile. It's very simple. You just need to input the wellhead temperature and sand phase temperature. In this case, I will use linear profiling method, but you can also input the detailed profile if you have the data from the wellbore measurement. You can input the measured depth, temperature, and the gradient will be calculated. So in this case, I will use this one, temperature and wellhead pressure. Okay, so it will be 90 and the sand phase temperature is 175. Okay, and deviation survey, okay, starting from 0, 0, down to, I need to check the casing. This one, beautiful. It's actually a vertical well, okay? But of course, you can also model the, the horizontal well, deviated well using Harmony Enterprise. It's very easy. Okay, so I think we are good. Okay, so let's try it. Calculate sand phase pressure. Hopefully the sand phase pressure has been calculated. So we can look at the production. Sand phase pressure. Okay. So now we can read the message again. Some parameters in oil properties are invalid or empty. Okay, right. So this is our next homework. Why? Because we input stock time barrel per day. Okay, so if you input the reservoir barrel per day, then actually it will be easier for the software. But if you input the stock time barrel per day, of course, at least you will need to input the oil formation volume factor, water formation volume factor, and gas formation volume factor, right? To convert from the surface unit to the reservoir unit. Okay, but that's our homework for the next video. So the focus on this video is actually how to import, how to add new data from new well into our project. Here in this case, I input this well and how we set up the Wellbore configuration. In the next section, we will try to populate more data into our project to describe our well until finally we will reach the analysis where we will perform something like flowing material balance, rate transient analysis, and so on and so forth. Okay, so until then, see you. Thank you so much for watching. And yeah, again, see you again in the next Eng-Man videos. Thank you.